So hello everyone. I hope all of you guys are doing great. So this is the second class of physical sciences for ninth class, and in this class we will be going ahead with some of the topics that we had studied earlier, right? We will be elaborating that and we will be starting some new concepts, right? So before we can start our class, so I will just show you a picture. Just think about it and elaborate it. Okay? Right. So students, what you can see in this picture. Yes, students? Right. We can see that one fellow is sitting here. This is an apple, and this apple is falling on the head of this person. Okay? Right. So now we have seen that this apple fell due to what is known as gravity, isn't it? We know that it fell due to gravity. And now let's see this picture. Okay? Just see this picture. Do you recognize which body is this? What is this, students? Yes, right. So this is Earth. This is Earth. Okay, right. So is Earth like a great circle? Is Earth like a circular body or a spherical body or something like that? Or is it in some other shapes? So what do you think, students? Like Earth is a pure circle, or it has, or it is of more or like this shape. So what is the shape of the Earth? Right. You can take the reference from the picture also, right? So we can say that Earth is, although Earth looks a sphere, Earth is looking as a sphere, but Earth is not actually a sphere, right? The exact shape of the Earth is called as geoid. What we say? We say geoid. Okay, students, the shape of the earth is geoid. And by geoid, what we mean? We mean that the earth is flattened at poles, right? So earth is flattened at poles and bulged at equator, right? So the earth is flattened at poles and bulged at equator, right? So we know that this will affect gravity, isn't it? This will be affecting gravity. So let's see how this affects gravity, students. Right. So as we move from pole to the equator, right? As we move from the poles to the equator, the radius of the earth increases, right? So if I will draw, so this is the equator and this is the distance from the pole, right? So let's denote this. Okay, I'll be using some other colors again. See here, with the green line, I am drawing this equator, right? With the green line I am drawing equator, and with the red line I am drawing the lines connecting the pole, or we can say axis, right, students? So what we will see that the length of this green line or the equator will be more, means that point this and point this, the length of the green line will be more as compared to the red line. Why? Because earth shape, the earth shape is what? Earth shape is geoid, and because earth is a geoid, then what will happen? It will cause different types of gravity, right? It will lead to changes in the gravity. So as we move from poles to the equator, the radius increases, right? So the radius increases, and so the gravity decreases, right? So the gravity decreases from the poles to the equator, right? So to explain it very simply, let's point out this as a reference point. Okay, I am marking this as a reference point. Okay, so now distance from here till here, it will be less than the distance from here till here. Understood, students? So now what will happen? The gravity at the equator will be less, because we have seen our equation where it is said that gravitation g, we derive this equation, isn't it, students? We derive this equation, so we will see it in our next slide also, right, students? So the gravity decreases from the poles to the equator. Okay, students? right? Is there any confusion in this slide? No? So, okay. Then we will move ahead, right? See, this is the representation of the shape of the earth, right? So here we can see in this picture, the radius at the equator is denoted by RE, right? The radius at the equator is denoted by RE and radius at the pole is denoted by RP, right? So since earth has a flat shape on the poles of the earth, so the radius at the equator will be more than the radius at the poles, right? And this is a difference, right? So radius at the equator is 21 kilometers more than the radius at the poles. Okay, students? Right. Okay. Now we will see that we will see why this is happening, right? So gravity at the poles, this will be equals to what? This will be gm by r square at the poles, right? And similarly, the gravity at the equator, it will be what? Gm by r equator squared, right? So we can see, since this distance re is more than rp, then what will happen? Gravity at the equator, gravity at the equator will be less than the gravity at the poles, right students? Now can you understand this? Is there any confusion to it? Okay, so now we will say that as we move from pole to the equator, radius increases, right? As we move from the poles to the equator, the radius gets on increasing, right? And as the radius gets on increasing, then what will happen? The gravity will start to decrease from the pole to the equator. Okay, students? Right? Okay. So, yes, my dear students, now we have reached to a question. Okay, so let's try to solve this question. So this question states that the mass of the earth is 6 into 10 to the power 24 kgs and the mass of the moon is 7.4 into 10 to the power 22 kgs, right? So if the distance between the earth and moon is 3 into 10 to the power 5 kilometers, then you need to calculate the force exerted by earth on the moon, right? So here the value of gravity is g is given here, right? So let's try to find it out. So what formula will we apply? We will apply the formula for the force of gravitation. So this states that F is equals to g m m by r squared, right? So we have the value of g, right? G is 6.67, or we can take 6.7, right? So we can take it as 6.7 into 10 to the power minus 11 into mass of earth, which is 6 into 10 to the power 24, right, into 7.4 into 10 to the power 22 divided by 3.84 into 10 to the power 5 kilometers. So when we will solve this equation, then what we will get? We will get the result as what? We will get the result as F equals to 2 into 10 to the power 26 newtons, right? We will get this answer that F equals to 2 into 10 to the power 26 newtons. Okay, students? Right. So now let's proceed ahead. Okay. So students, here are some pictures. So can you see what these pictures are, students? Yes. Okay. He is an astronaut. Okay. Very good. Very good observation. He is an astronaut, right? And this astronaut is moving in space in all the directions. He is not pulled by anything, it seems, isn't it? He is moving in the space in all the directions, right? Yes, students. So, students, you tell me that this he is floating in the outer atmosphere. So, why is he floating in the outer atmosphere? Why is it not getting sucked down below? Yeah. Okay. So there is no gravitation in the space. Okay, is it so? Okay, so now let's try to learn it. Okay, right. Now I will just ask you a simple question, a very small question. So what is your weight? Who will tell me his weight? What is your weight? Okay, let's suppose your weight is 60 kilograms, right? Your weight is 60 kilograms. We will see how this is useful to us, okay? How we will be, how gravitation is useful to us. And for that, I have taken a random arbitrary weight that is equals to 60 kilograms, right? So in this module, what we will learn? We will learn the importance of gravitation, right, students? Okay, so there are different importance to the forces of gravitation, right? So the first is that the force binds us to the earth, right? This force of gravitation, it literally keeps us on the earth, right? If there will be no gravitation, then we will be also like flying around and around, around and around in the universe, okay? Right. Now, the second importance is that the motion of the moon around the earth, right? So let's see here. Suppose this is earth and this is moon. So what is happening? This moon is like rotating around this earth, isn't it? The moon is rotating around this earth. And why this is happening? This is happening because there is the gravitation of the sun and the earth that is pulling the moon towards it to rotate itself, right? Understood, students? Right. The motion of planets around the sun. This is also due to the gravitation only, right? And the tides, most important are the tides. This also occur due to sun and moon, right? This also occurs due to sun and moon. See here, what happens when the moon comes here? So what happens is that in the poles it becomes low tide, and at the equator it becomes high tide, right? So what is tide? Tide is the rise in the level of water in the ocean, okay? So tide is the rise in the level of water in the ocean. And why it causes? It is caused due to the gravitational pull on the moon, right? So tide is caused due to what? It is caused due to the gravitational pull of the moon and the sun, okay students? Right. So, yes, students, we have reached another quiz here. So, the quiz states that which of the following is the importance of gravitation, right? So, the first one is force that bind us to the earth. It is called as gravitation. The motion of moon around the earth. It is gravitation. The motion of planets around the sun. It is gravitation. It is happening due to gravitation. The tides occur due to the motion of the sun and the moon, right? Or all of the statements are true. What will be your answer, right? I will give you 10 to 15 seconds to think about it, okay students? Right. So just think about it. Okay, so I see the answers coming, and the answer is all the above, right? So all the above is the correct answer. So the importance of gravitation is it is the force that binds us to the moon. It is the force that keeps the motion of the moon around the earth. It is the gravitation is required for the motion of planets around the sun, and the tides occur due to the gravitation of sun and the moon. Okay, students? Right. So now let's proceed forwards, right? So students, I will just tell you to observe what you can see in this picture. Okay, students? Just try to observe what you can see in this picture. Okay? Yes, these are various equations of motion. Yes, students, these are the various equations of motion. The first equation is V equals to U plus AT, right? So V is the final velocity, U is the initial velocity, A is the acceleration, and T is the time, right? S here stands for displacement, right? So S stands for displacement. Now you just observe these equations of motion. So the first equation states that V equals to U plus AT. Right, students? V equals to U plus AT. Right. So S equals to UT plus half AT squared. Okay. S equals to UT plus half AT squared. Right. So V square equals to U square plus 2AS. Right, students? V square equals to U square plus 2AS. Okay. Now S equals to what? S equals to half U plus V into T. Right, students? Now, for the sake of convenience, we will just ignore this equation of motion here. We will be going ahead with these three equations of motion. Right? We will be going ahead with these three equations of motion. So now, what you have to do, we know that G is the, we know that small g, let me delete these things. Right. We know that small g represents acceleration due to gravity. Right. Acceleration due to gravity. So here A is also acceleration and G is also acceleration. So imagine this body is falling freely. Right. So this body is falling freely. So for this freely falling body, how can the equation of motions be calculated? Right? How will the equations of motion work in that place? Right? So just try to think about it. Okay, students? I'm giving you 15 seconds to think about that. Okay. Now let's start. So students, we saw that V equals to U plus AT, isn't it? We saw V equals to U plus AT. So A was also the acceleration and G is also the acceleration, right? So this A, when we will change it to G, the equation of motion will convert to V equals to U plus GT, right? It is for the freely falling body, right? These equations of motion, it is for the freely falling body. Okay, students? Right. So S equals to UT plus half AT squared, right? So when we will change it to for the freely falling bodies, then what, in place of displacement, what we will be measuring, we will be measuring the height, right? So suppose that this equation of motion states that a body starts from this point A and it goes to the point B. So this is the displacement of this body. Okay, but in this freely falling body, what we will see, a body is at height this one and it is falling to this height. So what is happening, it is actually covering some height, right? So that's why here is the component h written here, right? So s equals to ut plus half at squared, ut plus half at squared. This will change to what? Ut plus half at squared will change to h equals to ut, h equals to ut plus half gt squared. Understood, students? Is there any problem now? Okay, right. Now students, let's rewrite this equation as well, right? So V square equals to U square plus 2AS. Again, we can convert this A to G, right? So this equation of motion will become V square equals to U square plus 2GH. Right, students? This will become V square equals to U square plus 2GH. Right. So now let's proceed forwards. Okay. So this was the equation for the freely falling body. Right. Okay, students. Now let's suppose that I am throwing this body up. Right. I am throwing this body up. So what? How this equation of motion will change in that case? Okay, students. Let's write this equation of motion when I am throwing this body upwards. Okay. So for reference, I have put the equations of motion here. So let's try to write this equation. So for the first equation, it will become V. Okay, let me change the color of the ink. Right. So we will write V equals to U plus AT. So plus sign. When we were changing it for gravity, it will become U plus GT. But again, the difference is that this time we are actually throwing it upwards, right? So in place of plus, what will come? there will be a minus sign. Okay, students, there will be a minus sign. So V equals to U minus GT. Right, students? Similarly, here it will become H. I have already told you why it will become H. So H will equals to UT minus half GT squared, right? This will be the second equation of the motion. Okay, now let's write the third as well. So V square equals to U square minus 2GS, right? So this will be our last equation when we are writing it for the body that is being thrown up. Okay, students, right? So now we have, let's quickly recap whatever we have studied today. So in our today's class, what we have studied about gravitation and the equations of motion. Okay, students, what we have studied about gravitation and equation of motion. Okay, so now let's quickly differentiate between the gravity on the poles and the gravity on the equator. So we know that the distance, right, the radius of the earth at the equator is more than the radius of the earth at poles. So the gravitation at the equator, it will be less than the gravitation at the poles. Right, students? Okay. Understood this point? Right. Now, what are some important points that we saw about the importance of gravitation? So first one is that it is very important that it is the force of gravitation that keeps us fixed to the ground. Otherwise, we would have been flying all around, isn't it? Right. The second point is that the tides are caused due to gravitation, right? The third point is that the movement of sun, moon, and all other planets happen due to gravitation, right? Okay. The moon rotates around the earth, that is also due to gravitation, right? So now what are the equations of motion? Who will write it with me? Right. So now let's write the equation of motion, right? It is V equals to U plus AT, right? V equals to U plus AT. S equals to UT plus half G half AT squared. Half AT squared. Right, students? And V square equals to U square plus 2AS. So these are the different equations of motion that we have studied today. Now, what we need to do, we need to modify this equation for a body that is falling downwards. In that case, what we will do, we will just replace this acceleration term and this displacement term. Displacement will be replaced with h, right, and a will be replaced with g, right? So v is equals to u plus gt, h equals to ut plus half gt squared, and v square is equal to u square plus 2 gs. Okay, students, so this is the equation of motion for the freely falling bodies. Okay, students, now we will just modify this equation for the bodies that are being thrown upwards, right? So in that case, we will change this plus sign to minus sign. So v square equals to u minus gt, h equals to ut minus half gt square, and v square equals to u square minus 2gs, right? So this was all we have learned today. Now let's come to our homework part. So in the homework, you need to find out the mass of the sun and the moon and find out the acceleration of the earth. Then find out why the acceleration is not sufficient to move towards the moon, right? We have seen that the earth is not actually moving towards the moon, right? So you need to find out that why earth is not actually moving towards the moon, why it is rotating around the sun. Right, students, this is your homework. This is a very creative homework. I hope you will all do it. So we have reached the end of our today's class. So I once again thank you all for attending my today's class.